Welcome back to ArmanisMath. This is lecture number 11, and we are talking about 4 different ways, 4 different formulas to find the area of a given triangle. Four, not just one. And that's what we're going to be discussing today. So welcome aboard. Make sure that you have your notebook ready, and let's get started. So first thing is the warm-up, as we always do. You are looking at 3 different triangles, and we could start probably labeling them as such. So we have down here is E, down here is EG, and every tick mark here and this grid is 1 unit. So it's 1, 2, 3, 4. The bottom here is in the chat, please. Can you tell me how much is the units if we're counting by 1 down here? How much is EG? How long is EG? Good. Got my eyes down there on the chat, and also here. Here's a 5. And if you could count upward, if you could count vertically here, also every tick is 5. How much do you think all the way to O? How much do you think we've got here? What's the height for this thing? And I see a couple answers here. 15. Let me choose a different approach on that. This one here. So I got an answer down here saying that this is 15. This thing is 15. Okay, so based on the formula that we know thus far for the area, it's area of a triangle is 1/2 base times height, and the base here is let's say area for triangle. Let's be more specific here. I'm doing EGO. EGO. It's not an E. EGO. Cool. So area EGO is 1/2 base times height. The base of EGO is EG, which is 1/2 times the 5 and times the 15. The height is 15. That's H, or 15. Okay, and if you use a calculator, you will get 37.5. 37.5. So now I have a question, because if this is 37.5 square unit, obviously, whatever the unit is, if this is true about EGO, what about EGF or EFG? EFG. How much is that? What's the base for EFG? EFG. In the chat, EFG base would be what? What's the base? I see that. So it's 5. 5 doesn't change. And apparently, actually, 5 doesn't change for all 3 of them. They all have the same bases. Now the question becomes, do they have the same height? And it turns out to be yes. Actually, they do have the same height. Interesting. So if I were to, because remember, the height of the triangle has to make a 90-degree angle with the base. One more time, the height of the triangle. To be considered as a height in the triangle, you have to make a 90-degree angle with the base, whatever your base is. So if you're down here, the base has to be 90. Okay, same here. If you guys remember here, this was 90. And also, just for the sake of demonstration here, obviously, it's going to make a 90-degree angle with this base as well. So that's the height. So the height has to make a 90-degree angle, has to be perpendicular to the base. And in this case, if you look closely here, I'm reaching the same height. I'm going all the way over 15. And then this blue line all the way up to 15. And then this blue line again, all the way up to 15. And you could tell that this is same height. So I'm expected actually to see the same area for all three of them. But one is skinny, one is chubby. Well, that doesn't really matter mathematically. What matters is, do they have a height? Do you have the same base? Then you will end up with the same area, regardless of what you do. What's the shape is going to look like? Same. So the base is 5 again, and the height is 15, and you should end up with 37.5 square units. Also, same thing with the last one is going to be EMG. EMG will have the same 37.5 units squared. Okay, so the reason is, can somebody tell me what's the reason? Why do they have the same area? In the chat, please. Why do they have the same area? They look different. I mean, they don't look alike at all. It's an hat. Thank you, Etzel. Okay, here we go. Objective today. You will be able to use 4 formulas to find the area of given triangles, including Heron's formula. So 4 different formulas, including Heron's formula. All right. Any word from the objective in the chat, please. Just pick any word. A formula, and 2, an area. Right? That is true. All right, let's get going. And for this one, we are going to where do we actually use this in life? Well, in real life, you use a lot of triangle areas, obviously. One of which, for example, whatever you want to paint a wall, and the wall or area of the wall, and you just want it to have a triangle shape in the painting. Well, you have to have the area that you need to paint. Because what if there is too large? I mean, or what if there is too small and you don't want to just buy this container of paint that costs too much? So you use the area to find out how much square footage you need to go and get that container instead of a big one, unless if you have a big wall, obviously. What else can you think of? You could put some in the chat. Other examples you think that we could use the area, we could put some in the chat. All right, here we go. So first thing we're going to do is to use our good old friend, half base times height. Okay, given the base and the height of a triangle, probably a 4th grader could do it, but hey, we're here, so we could do that as well. So let's just show our 4th graders that we could do this. All right. And help me find the base here, the area, because I do have a vertical, perpendicular, I should say, a perpendicular line with the base, so I'm able to determine the height. There's a perpendicular line with the base that tells me the height. So can somebody tell me what's the base here? What's the base down here? Every tick is 1 again. 1 and 2, 3. 22, I got that, and base. I highly advise that all of you share, please, and comment, and be plugged in with me. Don't just sit there and be a spectator. Okay, math is not spectator. You have to. You can't do math just by looking. So this is 1/2, and the base is all the way from here to there. So this amount here, and your friend just give us 22. And how much is the height? Can somebody tell us the height? I see somebody said 7. That is true. So this is 22 times that 7. Now it's up to you. I wouldn't just rush for a calculator. I don't know. I'm a big I'm a big fan of reducing, simplifying before I multiply. So I would make my life easy. For example, the 2 and the 22. This is gonna make this guy 11. I have no fractions anymore. I've got 11 times 7, and 11 times 7 will give me a good looking number, which is 77. Once again, square unit, and that's the area of this triangle. All right, so We all love this. We all love 1/2 base times height because obviously we've seen it a lot. Perhaps when we were toddlers and stuff. Okay, probably not. Maybe, yeah. Just depends. Here's another thought here. Well, not everything has a perfect base and height. What if you can't determine the height? What can you do? Well, one case here is called the oblique triangle. An oblique triangle is a triangle with no right angle. There's no vertical line that I could make to present it as a right triangle, and which means I can't have a height, right, with a base easily. So we call this thing oblique triangle. The area is 1/2 the product of the length of the two sides. So you basically have got two sides. Obviously, this picture is not pretty accurate here. It just looks like a triangle, maybe something like that. Something like this, maybe, or something like this, or something like that, something like that. And what we need to do is just to use this formula here because it is helpful to find the area of an oblique triangle. So luckily we have this formula here. By the way, I'm not going to go into details how these formulas came to exist, but some of them came from some of them are driven from the law of sine, law of cosine, Pythagorean theorem, etc., etc. Okay, so if you have an interest in that, you could comment in on YouTube when you see the videos. You just tell me that we are interested in knowing more about how did these come to us. How do we drive these? So it says 1/2 base times height sine A, which means sine the angle between them. So let's say this is A and B and C. Where is this dude here? And obviously, you know by now that uppercase A is the angle, lowercase a is the side, uppercase is always the angle, and then facing lowercase b, which is a side, uppercase C is an angle, facing lower or little case c is a side. Okay, so basically what they're saying here is you have a side and an angle between them. Side A, which is this guy, side, I should say side B, which is here. Choose a different color for that and just show you what exactly is meant here. So I have side B, this guy, and I do have side C, which is this guy, and we have angle A between them, angle A between the two sides. Okay, and that's angle A here. So basically I have a side, angle, side. If you have this set up, you could use this formula here to find the area. So here's an example. It says find the area of the following oblique triangle given two sides and one angle. Angle A is 29 degrees. We're given one angle, which is A in this case, and two sides. That's the B and C in this case. Okay, so B and C. That's a side, that's a side, and this one is an angle. So using this formula, I have 1/2 of B, or the side is 49. 50 is C, and sine the angle between them, which is 29 degrees. A big fan of actually drawing things. It makes sense when you draw things. It doesn't have to be accurate. It's just kind of a little thing here for you to picture. So for example, if I want this to be A, B, C, so I am given side B, which is this dude here, 49, little b. And I'm given also a side C, which is this dude here, which is C equals 50. I am also given an angle, which is angle, oh Lord, 50, which is angle A. That's this dude here. And this guy is 29 degrees. You're able to see that? I could change the color here. 29. Okay, 29 degrees. So basically, I'm just making use of this formula here. And 1/2 base times height, I obviously, again, once, as always, simplify before I multiply the 2 and the 50. That's going to give me 25. It's not going to be like huge of difference, but that's less fraction, I guess. So now I've got myself, I am looking at 49 times the 25 times the sine of 29 degrees. And I did that earlier, and I came up to the area of a triangle is 593.89. And obviously square unit, as always, whatever the unit is. Okay, whatever the unit is, that's, you're gonna have to square that. Okay, that's the area of this triangle. Another formula. So this is now the third formula. The first one was 1/2 base times height. The second one was what we just discovered here, which is 1/2 base, 1/2 one side times the other side times the angle between them. And now this one is area of a triangle formula driven from the law of sine. So I have one side squared, which is the given side, obviously. So you got 20 here. And then you have sine A, sine B divided by 2 sine the same side that you started with. So I'm going to just have to emphasize that this is a side. Maybe I could highlight that for you. This side here is the same as the angle that corresponds to that side. Okay, example number 3, find the area of the following triangle given 3 angles on one side. So how do you do that? Well, I could use that easily by looking at this formula here, which is driven from the law of sine. So now area equals c squared. Well, this is your c here because that's facing uppercase C. This is lowercase b. This is lowercase a. And I have the angles here. See the angles already listed? Not sure if you can see that. A, uppercase C, uppercase B. So I have c squared, which is 20 squared. Excuse me. Sine of A, sine A, 45. What? Sine A, 45. Okay. I guess we know sine 45. Sine B, 60. What? Yeah, I know sine 60. So in the chat, please go ahead and give me sine 45. Whoever's going to get there faster. Sine 75. Sine 45 in the chat, please. Sine 45. We know that from, oh yeah, from special right triangle, so special. Sine 45, somebody else give me sine 60. Sine 60. Come on, champions. You could do it. Yep, I see that, Pike. You are telling me that sine 45 is square root of 2 over 2, and that is true. 20 squared, which is, by the way, 400 now. 400. Sine 45 is square root of 2 over 2. Sine 60, come on, sine 60. Come on, champions. Almost there. Sine 60 is, okay, I see that again. Yeah, see that, Ethan? Yep. Got square 3 over 2. What's cosine 60, by the way? I'm just curious. What's cosine 60? $75. And I'm going to use my calculator for 75. Sine for 7, sine 75, 75, 75 equals, I've got 0.965. So I'm going to, yep, 1/2. I see that. I see that in the chat. Sine 60 is cosine 60 is 1/2. Great. Yeah. So we're not going to forget things, right? 965. 965. You could take another one if you'd like. Another decimal. So now you do have to use calculator. I don't like it, but we have to. So this is a 2. I'm still not going to give up on simplifying. This 2 is going to go with this. Obviously, it's going to make this 200. So it's 200 times square root of 2 times square root of 3 over 2. Or you could just use, you also could use this. Okay? So it's up to you. I am looking at, after simplification, after simplifying this, I actually am looking at an area of approximately does anybody come up with any numbers here? I got 100. Hello. I got 20. Hello. Yo. 6.79. Ooh. 100 to 126.79. That's the area for this here. Okay. 126.79. Here is Heron's formula. Area of a triangle, Heron's formula is driven from the law of cosine. So we had one previously driven from the law of sine. This one is actually driven from the law of cosine. This guy actually lived in Alexandria, Egypt. So think about a couple thousand years ago, and this is what he came up with. He said that you do not need any angle. Excuse me? No angle needed to find the area of a triangle. Hey, there's more. You do not need any height. Wow. No height? No. No angle needed. All what you need to tell me is the 3 side lengths of the triangle, and I will be able to tell you the area of a triangle. That's powerful. Seriously. I mean, no height, no 1/2 base time, no, nothing. So what you will discover here, or this guy discovered, is you only have to have 3 sides given to you. 3 sides given, and here Heron will tell us exactly how do you get the area of that triangle. And the formula goes like this one. The area of a triangle is going to be using this formula. It's something called S here. There's S here, S, which is a semi-perimeter. Semi-perimeter. For example, let's say I have a 10 and 2. Well, that's not 2. Let's say 8, and I have 12. So you add these. You add them up. Perimeter is like you're walking, right? Walking. That's fast walking. You're walking around. You're getting the perimeter. You're walking, and then you split that over 2. That's going to give you the S. That's how you get the S. It's a semi-perimeter. It's whatever you're adding these sides, A plus B plus C, divide that by 2. That's what's going to give you the S factor. Now, once you get the S. Once you get the S, you just have to plug it into this formula here, the square root of this S that you got, the special S. And then S minus the first length, S minus the second, S minus the third, and you are under the square root. So let's take an example of this. A garden has a triangular flower bed with sides measuring 2 yards, 6 yards, and 7 yards. What is the area of the flower bed to the nearest tenth of the square yard? Well, picture worth 1,000 words, so I'm just going to put a picture. So let's say we have something like this. Okay. And this one maybe, obviously it's not drawn to scale here, but 7, and perhaps this is, it doesn't make any sense, but hold on, let me try to make it better, just a little bit better. Okay, hold on a second, hold on. I guess we can do better. A little bit realistic here, so let's try something like maybe, yeah, probably. Okay, anyways. Let's say this is 7, 6. It's not drawn to scale. Okay, 3, 2. So now they're asking you to come up with an area. You want to paint. Maybe you want to put grass in this thing. So you just wanted to know the area. So you can go to your local Home Depot, maybe, or Lowe's, or somewhere to get some supplies or for this. So, well, you're gonna have to find the S. The S is the sides added, A plus B plus C. So which one is A, which one is B? What doesn't really matter. Maybe this is A, maybe this is B, maybe this is C. Doesn't really matter. Divide that by 2. So that's going to give you a 7 plus 6 plus 2 divided by 2. 7 plus 6 plus 2 divided by 2. Well, 6, I have 8. 7 is 15. Divide that by 2 is going to give you 7.5. Okay? So you will end up with 7, different color for this guy, 7.5. So the S factor is 7.5. Okay, now let's think a little bit here. This is not obviously the end. He said you could use that S. You could add the perimeter divided by 2, which is called semi-perimeter, and then use it in the area formula. And the area for Aaron's formula is the square root of square root of S times S minus A, S minus B, that's an S here, times S minus C. And that should give you the area. And we see here that S is 7.5. And then 7.5 minus 7, 7.5 minus 6. Oh, Lord, this thing. And 7.5 minus 2. And you are under the square root. Don't forget that. I'm probably going to use this tool here. Okay, so you are, you are under the square root. So I would come here, under the square root, just like that. Okay, that's the area for this guy. And obviously you probably need a calculator for this one. I put that into the calculator. And let's see what you guys come up with. Can anybody chime in? Tell me how much you got for this? How much you got for that? Hello, for that? Well, believe it or not, this whole thing, 5.6 is the area for this triangle. I'm glad we caught that mistake. 5.6. Okay, 5.6 is that, and square yards. Okay. Here is a quiz for yourself. I'm gonna pause for a few seconds. So when you're watching the video, you just need to pause and then work this out. I'll put the answers in a second. Just look and a few seconds before I put the answers. All right, here's the answer. And once again, this is time for 1 minute of hope with Armani. I am pleased with what I'm seeing responses wise and assignments and things and questions. I am happy to see a lot of you graduating. I know it's not what you expected. As long as you have your family with you to celebrate and friends, even though that they can be with us for the tassel and things, but you guys are awesome. If you're a student, if you're not a student watching this, hopefully you learned something today. And we're gonna make it. You guys are awesome, and I love you all. And remember that our hope, it comes from above. Our hope comes from God, who helps us during hardships and circumstances like that. Okay, wish you all an awesome day, or whatever the time is right now, and enjoy it. Love you all, and take care of yourselves.